Now we're going to look at graphs where we raise the function to some power, and that power is a whole number, or positive for that matter as well. So things we notice, if we look at the derivative, when we differentiate using our chain rule, so bring down the power, lower the power, diff the inside. A couple of things we notice here. Where the original function had an x-intercept, it's now going to be a stationary point, because with subbing function x equals 0, so the derivative of the new function will be 0. So every x-intercept will become a stationary point. But also, it's times the derivative, so everywhere on the original graph where we had a stationary point, that will remain a stationary point. Yet the y value will change, but that x value will have still a stationary point. Okay. So all stationary points will still be stationary points, as I say, other than the y value. So here's our good old random curve. Let's plot some in. There we go. Now, I'm doing to the power of 2 for this one. So this stationary point, the y value, well, it's bigger than 1, so when I square it, it's going to get bigger. This particular one, you'll notice I changed the scale a bit, so this is clearly less than -1, or technically greater than -1, but you get what I mean. So when we square it, it'll actually become smaller, but of course negatives will become positive, so it's now on the other side of the axis. And every one of those x-intercepts will now also be stationary points. And of course they'll have to be turning points, because function x squared could never go negative. So we know they're all going to just turn on the x-axis. Okay. The vertical asymptote is going to stay. I mean, if you couldn't find it in the original function, you're not going to be able to find it in the new function. My horizontal asymptote, again the value is smaller than 1, so when I square that, it's going to get smaller. So I've lowered the horizontal asymptote. Now 1 becomes a key point, because when you square 1, you get 1. So we know that point remains on the curve. But of course, if we have a number that's bigger than 1, I'm just talking about the magnitude here, then the curve's going to get bigger. So it'll be above the original graph. So whenever the original graph was above 1, my new graph will be above the original graph. But whenever the original graph was less than 1, my new curve will be below the original graph. Because when you square a number smaller than 1, the number gets smaller. So when that comes into drawing, well, 1, as I say, is important. So let's plot those points in. -1, of course, will reflect up to +1 because we're squaring. So we'll plot that there. But when I'm now drawing in the graph, when it's below 1, my new curve will go below the old curve, but of course above the asymptote. Then we'll hit 1, but then we'll go above the old curve. So it's something like that. So at each point, that's what I'm doing. A bit hard with the negatives because of course it's down below. I mean, it's becoming positive. But here we're going below the original curve, 1, above the original curve, 1, below the original curve, and there's our x-intercept, which has become a stationary point. But then we're going, well, again, the negatives makes it a bit hard to show, but it's actually below the height of that one below. And then we turn again and go towards our asymptote. So we're sort of twisting around the original curve. So let's get rid of the construction graph. There's our graph, function x squared. So that was an even power. So an even power is always going to be positive, of course. An odd power, basically we do it the same way, but now the sign will stay the same. So we can have negatives. So let's go back to our random curve. We now do function x cubed. Let's cube it. Okay, well, my stationary point goes a bit higher now, because cubing obviously is going to go bigger than squaring it. My x-intercepts, they will no longer be turning points though. They will now be horizontal points of inflection, because they're still going to be stationary points. There we go. My horizontal asymptote still comes down lower. Vertical asymptote, well, that remains. And where's my next point? There we go. 1 cubed is 1, so 1 stays the same. Negative 1 cubed is negative 1, so it stays the same. But now we can still use the same idea of below and above and so on. But it gets tricky around these x-intercepts because remember they're horizontal points of inflection. It got a little bit dodgy on mine. It's very hard to do it in PowerPoint. But they're meant to be horizontal points of inflection as I was coming through. But you'll see it still goes below, 1, above. Here we go. Below, above, inflect, below, above, below, inflect, and so on as we go through the graph. A very wobbly, dodgy graph. But there it is.